Zayesh. I have a master's in education. I'm a maths teacher. In this video, we're going to be talking about factorizing cubic polynomials. Just a little bit of background into factorizing. Now, factorizing was actually introduced by ancient Greeks. This is per history. Now, from the perspective of believers, and Christians who believe, in the realities of God in the Bible, we know that math actually predates that, because the Bible tells us that in the beginning, God created heavens and earth, and then there was the first day, the second day, the third day, the fourth day, and the seventh day God rested. And we can already see some evidence of arithmetic over there. And we also see that the Bible tells us when God spoke to Job, he said, do you know where I laid the foundations of the earth? Do you know where its limits lie? Now we can already see that there's the concept of limits being introduced through the scriptures. And specifically, if we look at Matthew 14, chapter 13, verse 13 and to 21, we see the great miracle that the Lord Jesus performed, and it was 5 loaves of bread and 2 fish, which fed 5,000 people. Now, is that not an example of factorizing? Food for thought. All right, so let's go into our topic of the day, which is factorizing our cubic polynomial. Now, as per rule of factorizing, what we know, if we got an expression like this, factorizing actually makes it easier and simpler. One of the goals of mathematics is to simplify everything. So we're going to be trying to simplify all this and make it very, very simple. Now, we do that traditionally, as we know. We need to isolate the first two terms like that. Okay, and then we have the second terms. So let's try factorizing it. So here we have the highest common factor between x to the power 3 and x to the power 2 is x to the power 2. So we're going to factorize that. And then we open brackets. We have x here, because when we multiply that, it gives us x cubed plus, and this is x squared, so we don't have to have anything, we can just have 1, all right? And the next thing here is minus. Now we're going to try to get the highest common factor between these two, and it's going to be 2x. Now, in this case, just 2, because we don't need x. This term doesn't have an x. Okay, open bracket. We've got a 2x here, and we've got inside here minus 2. Okay, this becomes a minus because there's a minus outside here. Minus and minus makes a plus. Now, if we look at this factorization that I've just done, this is really not possible because we don't have a common term. You see, we have x plus 1 here, we should have another x plus 1, which is not the case. So this does not work. So I'm going to have to erase that. Okay, because that's not possible, so what we're going to do is try to find a number. Let's think of a number that we can use instead of x. We've got the expression here, x cubed, x squared, and x here. So let's think of a number that we can use, and if we substitute the substitution to x with that number, we can have a 0 in our polynomial. And I will think of a number 1, all right? I'm going to use the number 1. So I'm going to try to substitute 1 to each of those terms that are on top here. So I'm going to do 1 cubed plus, instead of x, another 1 squared minus 4, in this case times 1 plus 2, and let's see if it equals 0. So I'm just going to do 1 cubed, it just means 1 times 1, which is just 1. So okay, 1 plus 1 squared is just 1 minus negative 4 times 1 is negative 4, then plus 2. Okay, see if it equals 0. Now the next thing to do is 1 plus 1 is 2, minus 4 plus 2 equals 0. So here we got 2 minus 1, it's pretty much subtraction of an integer, smaller number subtracting a bigger number. So we have here 2 minus 4, it gives us negative 2. Okay, plus 2 equals 0. Now here we have 0 equals 0. So we can see that the number 1 satisfies the purpose of factorizing this expression. So it is actually a factor. So we're going to erase this. That means x equals 1 actually is a factor. So that means if we have x minus 1 equals 0. So that means here that this satisfies the purpose of the equation. Okay, so x minus 1 is actually a factor. So I'm going to put it over here, x minus 1. Now, the next thing we want to do is, I'll erase this. Next thing we want to do is, we still don't have a factor of the whole expression. Okay, we found one that is possible. So the next thing we want to do is to divide, we'll try to divide this by this expression. And that we can do it just by long division as it's done. Now if you remember long division, we have, first of all, we divide, we multiply, and then we subtract and we bring down. Okay, so this is pretty much just long division. So I'm going to write this whole expression, this whole polynomial here, x cubed plus x squared minus 4x plus 2 divided by x minus 1. So I'm going to start off by doing this. First of all, I'm going to divide. So I will start off with these, the term with the highest exponent, which is x to the power 3. So if I divide x to the power 3 divided by x, I'm supposed to divide this by this whole expression. So I'm going to start off with this, with the x here, and then that gives me x to the power 3 divided by x is the same as having x times x over x. And pretty much what we do, we cancel out. Okay, we divide x by x, and we remain with x and x, so which is x squared. So I'm going to put x squared here. The next step is to multiply, so I'm going to multiply this times this expression, and then I'm going to have here x times x squared times x gives me x to the power 3, and then x squared times negative 1, it gives me negative x squared. And what I need to do now is to subtract this minus. Now notice when we subtract this, what will happen is by subtracting x minus here, it affects all the signals that are inside the brackets. In this case, we're going to have minus, making this minus a positive. So x to the power 3 minus x to the power 3 is just 0. And then we have x2 plus x2, it gives me 2x squared. So let's continue. So then we bring down, it's the next step. So let's bring down our